This week's challenge is going to be mainly on the cold steel Rajah III. Going to be a bit different than some of the other videos. What I'm going to do is give a brief overview and talk about this knife, and what you have to do for the challenge is point out every mistake that I make in the commentary, and you get 1 point for each mistake that you find and the correction that you actually give for it. If someone else successfully argues that a mistake that you pointed out isn't actually a mistake, they get that point and you have it deducted. If at any point you lose control, you're not able to have a sensible discussion and it returns to a personal argument or attack, you lose all your points and they get all of them. At the end of one day, whoever basically gets the most points wins the challenge. So again, much of the information presented in this video is going to be incorrect. So don't listen to what's said and try to use it again as a effort to learn about knives or performance to any extent. This is itself hopefully a discussion tool, but again, a lot of the information presented is intentionally false. So, to begin, the cold steel Rajah II is basically a scaled down version of the Rajah, which is a huge folder from cold steel. Cold steel president Jerry Buss is known for his infatuation with large folding knives, and some of them are basically huge, and Vaquero Grand was one of the original monster designs. This immediately brings up one of the inconsistencies in this design, which is the bolo style blade is generally found on larger knives, which are mainly used for chopping. On a knife this small, the immediate question is this blade shape, which has this again very wide forward swell, which is designed mainly to throw a lot of weight forward for your heavy power slashing or chopping type cuts, does that make any sense when your knife ends up being very light? And in regards to raw chopping ability, this is only about half that of the cold steel AK-47, which itself is not a very high benchmark for chopping performance for folders. So it's not really a powerful chopper, but it has a blade shape which is optimized essentially for that. The second point of inconsistency is kind of interesting. This sharpening choil or notch, which is basically on the blade to give a very clear transition between the unsharpened part and the sharpened or ground part. So when you sharpen the knife, you know exactly where to stop, and you don't end up with sort of a very vague transition that bleeds out into the blade that you will find on knives that don't have that. Now the paramilitary from Spyderco didn't have one originally, and again you end up with this sort of region right here which sort of goes dull because it's very difficult to sharpen all the way back to this, and you can see it's obviously not even ground all the way back to it because the primary grind has to have some kind of plunge line or cut. And I added a sharpening notch there, or a choil notch. You don't always need that, of course, and the Spyderco Air essentially has a dropped blade, so you can sharpen the full length of the edge, and essentially the blade is actually lower in the cutting profile than it is in sort of the transition or tang area of the blade, and this again allows you to sharpen all the way back. And you can see the same thing on the Aries from Benchmade, which again also uses that drop blade profile to again allow you to very clearly separate the sharpened and unsharpened parts. But the cold steel has the notch. The silly thing is, though, the edge doesn't go all the way to the notch. So you have all the weaknesses of not having a notch, the sort of vague area that's blunt, that can't be sharpened, and that you have to move forward on the blade to actually get to the sharpened area. But you also have the weaknesses of a sharpening notch, things can sort of catch and snag in that sort of area, and some people don't like the looks of it. and you have none of the strengths of the sharpening notch because you didn't actually sharpen all the way to it. That's rather silly. The other point about inconsistency is that the triad lock, which basically takes your standard lock back and adds this pin here, designed by David Boy, to basically stand in between the blade and the actual lock bar. So you can see there's the pin right there. So if the blade is overloaded when it's locked, unlike on this, which is powder coat Delica in ZDP 186, when you overload the blade in the lock position, the blade comes in contact with the lock bar and the forces are directly between the blade and the lock bar. Now, as I've said before, you generally don't want to have forces directly between the locking mechanism if you can avoid it, because it can lead to premature wear and failure. And that's what this does here. So it puts the force on the actual pin, and the pin then transmits the force to the blade handle. My question is, because this handle is actually made from Grivery, which is a thermoplastic with a nylon family, it does have liners, which you can see, but I'm actually concerned, is the actual failure mode going to be simply the deformation of the actual handle, because of the fact most of the handle is essentially this Grivery material, and no matter what fancy names you want to put on it, it's essentially a plastic. So when this is overloaded, is the weak point now the actual plastic handle relative to the actual metallic parts of the lock itself. Now, a little bit about performance. The edge is decently thin and ground at a relatively low angle, and there's much more specifications number wise in the forum links if you want to get into specific numbers. However, when I started to do some initial cutting, one of the things I like to do is sort of whittle some wood, basswood, hickory, pine, spruce. The performance was rather low, so I normally use as a benchmark my Mora number 1260, also added a little sharpening notch. You can see this is starting to develop a bit of a recurve because it lacked one, and I'll flatten this out the next time I sharpen it. And this performed relatively decently. Edges around 10 degrees per side, relatively thin stock. Completely outclassed this. I mean outclassed, it was almost in a different order of magnitude. That was rather surprising, because again, edge was relatively decent in terms of thickness, and I expected it to be somewhat comparable. Yes, under heavy cuts I expected be a bit of a difference, mainly because of the ergonomic issue and the fact that I had to cut so far forward on the blade of the Rajah III, it was going to give it a leverage advantage. I knew that was also going to be an issue. But even under light cutting, it was nowhere near comparable. Then when I checked the edge angle a bit more carefully, this was actually almost chisel ground, although it didn't look like it. So there's your basic standard chisel grind from Warren Shakira. And what you have, of course, is a blade that's flat on one side and all the grinding is done on the other. It's very critical that you get the grind on the side that suits you. When you're doing most power cutting, if you're right-handed like this, most of the force is actually going to be on this side of the blade. So the very heavy bevel on this side, the material tends to fold away from. This increases the force on this side and thus increases the cutting ability. Unfortunately, the way that the bevel was lopsided on the cold steel Rajah III, the very heavy angle was actually on this side of the blade, so it was chisel ground on the wrong side for a right-handed person. So the knife was actually acting like it was ground at an angle of 30 degrees per side, which explained its rather low cutting performance. And of course, like most of the folders, it was heavily buffed when I got it, and it had been stropped a few times by the original owner, but he hadn't done a lot of it, so it came with almost no slicing aggression as well. So I could easily put 50 pounds of force straight down into a piece of 3/8 inch hemp rope, and it wouldn't cut it at all, wouldn't even make a cut into it. I cleaned up the edge, and you can see how it's so much wider on this side than on the other, and again this is the very heavy angled side, so I brought it all the way down, and now it's getting relatively close to around 10 degrees per side, which is where most likely it will end up being. And that's normally where I would keep my heavy, sort of rougher use knives, and I'd go under that for precise knives like this, and this is significantly under 10 degrees per side. In fact, it's almost approaching the primary grind. You can see there's no real edge bevel on this as such. In regards to heavier type work, chopping and that kind of stuff, I did some work on alder. It's relatively decent. Again, you face a couple of issues, like for example where this area is blunt, you tend to have to chop further out on the blade and do some carving further out on the blade to get away from it, because if you hit the blunt area it skips, and you end up, of course, since you're not 100% precise like a robot, you can't get exactly here every time, so you tend to move a bit further out to make sure that when you skip a little bit back and forwards, you never hit the actual blunt part. And that again gets kind of aggravating, but I'll sharpen it all the way back to there the first time I do some heavy modifications on it. As I said, it cuts, or chops rather, about half as efficiently as the M16 from cold steel, which is relatively decent. The biggest problem with it was ergonomic wise. The inside of the handle scales was left 100% sharp. The end point here was very sharp, and the clip itself had very sharp edges on it. I did a really quick and dirty tumble wash on the clip, rounded out all the edges, rounded out the inside here, and rounded out the end of the handle to make it a lot more comfortable. In regards to grip versatility, it's actually relatively decent. The front little, of course, Emerson wave style opener there is nice as an actual thumb rest. It's mainly optimized for your hammer or saber type grips, but it's not uncomfortable in pretty much any grip, because of course the shaping is nowhere near, say, as extensive as the AK-47 from cold steel, which is very grip restricted. In terms of how to actually make a handle that's heavily contoured, this is one from Mike Gavco CKC Knives. You can see very extensive contouring on the handle. Even though this is very shape specific, as you can see, every aspect of this is fully rounded, and it's just very comfortable. You can even take this, which is basically the point of your index finger choil, and jam that straight into your hand. No discomfort, because again it's rounded in every direction. The only part on this which is a bit of a pressure point, you can see the very crisp transition line right here. Well, this leaves a bit of a point at the top right here. So in heavy overhand grips, which I use a lot because they present the material that you're going to cut almost directly in line with your index finger and thumb, so you can do a straight push with almost no torque disadvantage, so you get maximum cutting ability due to your efficiency being increased. So I use this a lot. So this little pressure point right here produces a low pressure spot when you're actually cutting, which makes it a bit uncomfortable, but I'll take care of that. Not a big issue. In terms of blade steel, this is an interesting point, and it tends to get more interesting every year. There was a time when this steel, S30V, was considered towards the extreme in terms of carbide volume and wear resistance, and it was, the premium sort of steel you could get in that respect. Cutlery steels have moved so far towards the extreme with steels like ZDP 189, M42, which is a crazy high-speed steel, high cobalt, commonly used in drill bits, that steels like S30V are much again to the left, showing a lower carbide volume. And of course on the extreme now you're working with steels like this. This is S125V. Again, insanely high carbide volume, insanely high wear resistance. So if you compare AUSA to something like this, it comes off as a relatively low carbon, relatively low carbide volume steel. But I mean, there are still knives being made out of steel similar to this. This is 1095 in your standard Mora, and you'll also find 12C27M, AEBL, and similar steels Well, AUS 8 is a high carbide steel compared to them. So again, a lot of it's going to depend on where you set your benchmark. Now there's a bit of confusion about AUS 8 and AUS 8A. They're the same steel. The A just stands for annealed, which is basically the condition that the steel comes in, and that just means it's ready to be quenched. Steel is essentially the same. The only issue that I found with this is that the edge tends to burr relatively readily and excessively, which is unusual for a steel of this class, because they usually have very low grindabilities, which means it's very easy to remove steel from them. So they generally don't burr very well at all. Where you tend to get burring problems is with steels, again, which have higher carbide volumes, such as this. And again, this is LMAX from ZT. And because they have a higher carbide volume, you have grindability issues, which means unless they're hardened absolutely perfectly, it's very easy for them to burr significantly. But since this steel is relatively easy, again, to grind, that kind of surprised me. But it's probably just the fact that it was overheated when they power sharpened it originally, so that'll probably go away. And the edge retention should be, again, decently solid. And the easiest way to sort of understand that, as I would put it, if you picked sort of a line and you put AEBL at one point and you put sort of VG10, ATS34 at the other point, well then AUS 8 would fall right in the middle of two of them in terms of long-term wear resistance. So again, it's going to depend on what your perspective actually is. I mean, if you're commonly using steels like M4 or ZDP 189 or S125V, you're going to find AUS 8 very easy to grind, and the abrasion resistance and thus long-term cutting ability in abrasive materials is going to be a bit towards the low side. But if you mainly use steels like this, 1095 AEBL, 19C27, MBS 26, those kind of steels, you'll find that if anything it will be towards the high end, so a lot of it's going to be where your actual perspective comes from. Overall, I don't think this is going to make it into my carrier rotation, even when I fix a couple of the problems it has. And mainly, it's going to come from the fact that the blade shape for me tends to be too restrictive. While there are some cutting advantages to this blade shape in general, I really find them only to be significant when the blade is a lot larger. So on the full style machetes, for example, you have a very wide spot up here, belly, which makes a very great chopping point for impact. You have the sweep or belly up here, which is very great for where you want to do sort of low force impact cuts where you allow the blade to slide along the material, which can be very good on hardwoods and stuff like that. And then down here you have this region which actually traps material and pulls it into the cut, because of course as material moves into this cut, say, it has to creep up along the blade, which decreases the force on the material and thus increases the cutting ability and allows it to cut that material even when the sharpness is actually lower, so it extends the life of the blade. But on this, every section is so small, they all sort of smear together and you really can't segment them out. So I don't think this is going to end up in my carry rotation. And I really don't think the AK-47 is either, because the grip is just too restrictive. So I think I'm going to break both of these by impact, because I'm very curious as to how the triad lock works and where the actual failure point is going to be. Not as much as the actual limits, because it's very difficult to actually put force requirements on them when you only have about one sample. But I'm just kind of curious to see what way it will actually fail, and it'll be interesting enough. And I'll probably sacrifice one or two of my standard lock locks just to get some relatively coarse measurements. And in regards to testing, one last point, a lot of the testing that knife companies do to show the strength of locks, or any type of testing that they do in general, is often geared more towards presenting large numbers than actual useful data. And one of the things that they do, which is very silly for locks, is that they load the blade in the horizontal or up and down position, and then they tell you what, usually they quote you a torque, because the torque produces a very large number. So they'll say something like, oh well, this blade failed at 1,000 inch-pounds of pressure, or something like that. And of course you hear 1,000, you're thinking, wow, that's a big number. It's obviously very strong. But of course you can change the size of the number by changing the actual units that you're actually measuring in. It would be like asking someone how much weight they could lift, and they could give you a number in grams, which would be massive. That's essentially the same sort of number thing that they're pulling here. The other thing, of course, that they do is they load it in like I said, that up and down plane where the knife is ridiculously strong. Anyway, I mean, even if you think about really heavily using folders and even cheap ones, it's very difficult to break a knife while loading it up or down because it's very strong. Knives actually break, of course, when you load them laterally like this. So when you're prying with the blade like that, that's when they're actually going to fail. And the other thing, they fail by impacts in this plane. And of course you subject the knife to impacts normally when you strike the spine or you're hammering on the spine to force it to cut through something. So I'm going to fail probably one of them by impacts and probably one of them laterally this way, and just have a look and see what actually happens. And like I said, I'll break one or two of my other folding knives just to kind of see where the actual failure points are and see, is there a dramatic difference in the triad lock, especially like I said, and these sort of plastic style handles will be rather interesting. Again, the challenge this week was to point out the mistakes that I made in this video. So again, there are many intentional mistakes in this video. Some of them are intended to be a little humorous, some of them are intended to talk a bit about materials properties, but again, don't quote anything that's said in this video as to try to make an argument about knife performance. A lot of the material is intentionally false.